All right, ready to dive into the world of locomotives. Diesel versus electric. Your source material on railway engineering goes deep, but we'll break it down. We'll uncover how these machines work, weigh the pros and cons, and explore why electric seems to be like the rising star of railways these days.
It's wild, this drive for efficiency and moving tons of weight. It's like shaped how trains have evolved, you
Yeah,
know?
totally. We see trains all the time, but the engineering behind them is incredible. To get this diesel versus electric face-off, we got to start with their ancestor, the mighty steam engine.
Yeah, gotta respect the OG. Steam engines were huge, but their way of turning heat into motion, let's just say they weren't winning efficiency
It's
awards.
all about that thermal to kinetic energy conversion, right?
Right. They were basically boiling water to get steam. That steam builds pressure, pushes pistons, turns the wheels, giant tea kettle on wheels, kind of.
Haha, I like that.
But you can imagine the downsides burning tons of fuel just to heat water. And only a tiny bit of that energy actually moves the train. Not efficient at all.
Not to mention all the smoke. Not exactly eco-friendly either.
Exactly. So as tech got better, it was clear a new era of traction was coming. Enter the diesel engine, total game changer.
The internal combustion revolution, things get seriously mechanical here. Instead of needing steam from somewhere else, these engines make power from within. Controlled explosions, hundreds of times a minute, to keep things moving.
Carefully controlled. It all comes down to this four-stroke cycle. Intake, compression, combustion, exhaust.
Okay, so I'm picturing pistons and fuel doing a carefully choreographed dance. Walk us through it.
Okay, so picture this. The piston moves down, sucks air into the cylinder, like think of it like a lung. That's intake. Then piston goes back up, compresses the air, the temperature inside goes way up.
Okay, things are heating up, literally. Then what?
Boom. Combustion. This is where the fuel comes in. At peak compression, a precise amount of fuel is injected, ignites instantly in that super hot air. This mini explosion forces the piston back down with a ton of force.
Boom. And that force is what turns the wheels.
Yep, that force rotates a crankshaft, which then transfers that rotation through gears and drives shafts all the way to those wheels. It's a whole relay race of mechanical energy, each part timed perfectly to keep that train moving.
Now, the docs mentioned different cylinder configurations. What's the deal with that? Some engines have 4, 8, even 12.
Good question. It's all about what the engine needs to do. Bigger engines, more cylinders, they make more power. Those are the heavy lifters. But they might not be as fuel efficient at lower speeds. So it's a balance. Power versus efficiency.
So it's a trade-off, like choosing the right tool depending on what you're doing. Cool.
Exactly. And this whole thing about efficiency leads us to the other player in our little deep dive, electricity.
And we're back, folks, diving deeper into the world of locomotives, electric locomotives to be exact.
This is where things get really interesting from an engineering perspective.
Last time we talked about diesel, those self-contained powerhouses. But electric locomotives, they get their energy in a totally different way, right?
You got it. It's like the difference between like a gas-powered generator and plugging straight into the grid.
Ah, okay. So instead of an engine burning fuel, they're drawing power from an external source.
Exactly. Think those overhead lines or sometimes even electric rails running along the track.
Yeah, it's like a whole electric highway system, just for trains. So what's the big advantage there? Why go electric?
Well, for one, electric locomotives have a much higher power-to-weight ratio compared to diesel.
Meaning they pack more punch for their size.
Precisely. Faster acceleration, higher speeds, especially important when you're talking about climbing steep inclines, hauling a heavy load up a mountain. Piece of cake for a powerful electric engine.
So they don't lose power at higher altitudes like diesel engines can.
Exactly. They're much more efficient at converting energy into motion, which means less wasted energy.
Makes sense. And less wasted energy means.
A smaller environmental impact, that's a major win for electric locomotives.
Right. Zero emissions from the locomotive itself. Gotta be good for cities and towns along the tracks. Okay, so electric sounds pretty great so far. But there have to be some challenges too, right? It can't be all smooth sailing.
You're right, there's always a trade-off. The biggest hurdle with electric traction is the infrastructure.
Ah, right. Setting up those overhead lines, the pantographs, that can't be cheap.
It's a huge undertaking, a massive upfront investment for those lines and support systems.
So how do railway companies decide when it makes sense to electrify?
Lots of factors go into that decision. They do these feasibility studies, compare the initial investment with the potential long-term savings, on fuel and maintenance and all that.
So they're weighing those upfront costs against those long-term benefits. Tough call.
Exactly. They got to look at traffic volume on the line, how much they're spending on diesel, even the expected lifespan of the locomotives they're using.
It's more complex than it seems at first glance. Now, the docs you sent mentioned two main types of electric traction, DC and AC. What's the difference?
Good question. It all comes down to the type of current used to power those electric locomotives.
Okay, so break it down for me.
So DC direct current, that was the go-to for a long time. Simple, reliable, those DC motors. Problem is, DC power, it loses juice over longer distances.
So you need a lot of substations to keep things going.
Exactly. Think every 15, 20 kilometers for some systems, that's a lot of substations.
Ah, so that's where AC traction comes in.
You got it. AC alternating current. It can travel a lot farther without losing power. Means you can space out those substations more, sometimes up to 70 kilometers. More efficient in that way.
Okay, so longer distances between those power boosts.
Yep.
But there's got to be a downside, right? Nothing's perfect.
Well, AC systems, they need more complex equipment on the locomotive itself. Got to convert that AC power into DC power. That's what the motors actually use.
So it's kind of a trade-off, simpler tech versus those shorter distances between power stops?
Yep, exactly. And that's why you see this whole patchwork of different systems used in different parts of the world.
Okay, now I'm really interested. Tell me about this global electric train system patchwork.
Well, take the 25 kV 50 hertz AC system, for example. That one's become like the gold standard for new high-speed lines, especially in Europe.
Why is that? What makes it so special?
It's come down to technology specifically. Advancements in things called rectifiers. They're what convert that AC power to DC power right there on board.
Ah, so it's like these rectifiers are doing the translating, making sure that AC power from the grid can talk to the DC motors in the locomotive.
Exactly. And this one type of rectifier, called a thyristor, it's been a real game changer. Super efficient, very precise control of the electricity. Made the 25 kV AC system way more practical and cost-effective too, which is huge.
So this 25 kVV system, is that what they're using for most new lines then?
It's definitely a popular choice, especially for high-speed rail, yeah.
Yeah.
But every situation is different, you know? Sometimes electrification isn't feasible, too expensive, maybe the geography is tricky.
Right, right. So how do they even begin to decide? When is electrifying the right call?
Well, they use this thing called energy consumption per kilometer, basically. It's a way to compare efficiency for different systems on a particular line.
So if a line eats up a lot of energy, electrification might be the way to go.
Exactly. Different railways around the world, they have these energy thresholds, right?
Yeah.
If a line's energy use goes above that, then it's like, okay, it's probably worth looking into electrification.
Interesting. So you've got all these factors, the cost, the energy use, the type of system.
Yeah.
It's a lot to balance.
It's a big decision. And we haven't even touched on the actual mechanics of the power delivery. Those overhead lines, the pantographs.
Oh, yeah. That's what I was just thinking. Can we zoom in on how that whole system works? It seems like a crucial piece of the puzzle.
Definitely. It's pretty amazing when you think about it. It's called the overhead contact system, and it's way more than just a few wires strung between some poles, that's for sure.
Okay, so break it down for me. What are the key parts of this system?
Well, first you've got the feeder conductors. Those are the big ones. They carry that high voltage electricity from the substations.
Okay, so those are like the main power lines.
Yep. Then you've got the contact wire. That's the one the pantograph actually touches. It's below the feeder wire, carefully positioned so the pantograph gets good contact.
And what keeps everything from, short-circuiting?
Good question. That's where insulators come in.
Yeah.
They're essential. They prevent any unwanted electrical flow, keep everything safe.
So it's like a carefully designed electrical dance up there. Okay, now what about the pantograph itself? That's the arm thing on top of the train, right? Seems like a small detail, but I'm guessing it's important.
Absolutely. It's the link between the locomotive and those overhead wires constantly drawing power to keep the train moving.
So if the pantograph fails, the train's stuck.
Pretty much.
Hmm.
And those things have to withstand a lot, especially as trains get faster. Even the tiniest imperfections in the overhead wire can cause problems bouncing, loss of contact.
Wow, that's intense. So there's got to be a lot of engineering that goes into making sure those pantographs can handle high speeds, right?
Oh, absolutely. As trains get faster and faster, the pantograph becomes even more important. They're constantly improving the designs, using new materials, all to make sure that power delivery stays smooth and reliable, even at top speed.
So we've talked about how these locomotives work, how they get their power, the different systems. But what about keeping them running smoothly? Maintenance, we haven't touched on that yet.
You're absolutely right. We can't forget about maintenance, whether it's diesel or electric. These machines need regular TLC to stay in top shape.
And that's where we're headed next. We'll be diving into the fascinating world of locomotive maintenance after the break. Back again.
Ready to explore the unsung hero of the locomotive world maintenance.
Right. It's easy to get wowed by the power and the tech, but none of it matters if the thing doesn't run.
Exactly. So paint us a picture. What does maintaining one of these behemoths actually involve?
Well, it's a lot more than a quick oil change, that's for sure.
Uh-huh, I bet. So we're not talking about your average tune-up here. Not even close. Think multiple layers of upkeep, and it applies to both diesel and electric. Got to keep those wheels turning.
Okay, so layers of locomotive love. I like it. What does that look like in practice?
You got your everyday checks, right? Technicians go over the locomotive fluids, visual inspections, make sure nothing's obviously wrong. Catching small issues before they blow up, that's key.
Makes sense. Prevention is better than a breakdown on the main line. But these things are workhorses. What about more serious maintenance?
Oh, yeah, they get that too. Regularly scheduled inspections, like way more in depth. Could be weekly, monthly, depends on the component. Got to stay ahead of any potential problems.
So it's like sending your locomotive to the doctor for a checkup.
Exactly. And then on top of that, every, say, decade or so, depending on how much it's been used, it gets a complete overhaul.
A whole decade. Wow. So what does that involve?
Basically, they strip it down, inspect everything, replace any parts that are even close to wearing out. It's like giving the locomotive a whole new lease on life.
That's incredible. It makes sense, though, after 10 years of hauling cargo or passengers, it deserves a little spa treatment. But with so many parts, I can't even imagine how do they keep track of everything?
That's where things get really high-tech. Remember those RAM studies from the documents you sent
These
over?
Rams. Yeah, it's coming back to me now. Something about reliability and safety.
Exactly. Reliability, availability, maintainability, and safety. They basically do these super in-depth studies on each locomotive.
So what do they do? Like give it a personality test?
Not quite. It's all data-driven, super smart. They look at the locomotive's history, how it's performed, what kind of maintenance it's needed, even stuff like the environment it operates in, all of that.
Okay, so they're building a whole profile for each locomotive.
Yep. And they use all that data to predict when parts might need replacing, to spot potential problems before they happen, and to create super efficient maintenance schedules.
It's like they're taking all those trips to the mechanic and optimizing them with like algorithms and big data and stuff.
That's a great way to put it.
Right.
RAM studies help keep things running smoothly, prevent breakdowns, and most importantly, keep everyone safe.
Makes sense. It's all connected. Well, we've covered a lot of ground today, from those early steam engines chugging along to these like super high-tech electric locomotives.
It really shows how far we've come. But the story of the locomotive, it's not over yet, not even close. We've got hydrogen fuel cells on the horizon, new battery tech. Who knows what the future holds?
It's exciting to think about. Will electric power continue to dominate? Will we see some kind of hybrid engine take over or something completely new?
Exactly. It's all about adapting, right?
Yeah.
Finding the most efficient, sustainable way to keep things moving.
Absolutely. Well, on that note, thanks for joining us for another deep dive. We've journeyed through the history of locomotives, explored the mechanics of diesel and electric, even peeked into the future of rail. It's been quite a ride.
It really has. Next time you see a train, take a second to think about everything that goes into it,
Yeah.
the engineering, the maintenance, the constant drive for improvement. It's pretty remarkable.
Couldn't agree more. And to all our listeners, as always, keep those minds curious and stay engaged with the world around you. Until next time.